and today's topic is binomial theorem, and bi stands for 2. It is a expansion of two terms. Simple understanding, if you have a plus b whole square, it is a square plus 2ab plus b square. A plus b whole cube, it is a cube plus 3a square b plus 3ab square plus b cube. And a plus b whole power 4, we do not remember that. So a plus b whole square we remember, and a plus b whole cube also we remember. A plus b whole power 4 we do not remember. So for the higher powers of higher indices, then we don't remember, we cannot remember also. In such a case, the binomial theorem can be comfortably utilized. So for that purpose, it is defined to be a plus x whole power n. I don't want to write the expansion because you all know that, and I want to write the general term here, NCR into a power n minus r into x power r, and r runs from 0 to n. R runs from 0 to n. This is the general term in the binomial expansion. So from this general term, we can find out whatever the term you need in this expansion, and understand the number of terms in this expansion will always be the power plus 1. If you take a plus b whole square consists of 3 terms, that is a square plus 2ab plus b square, power plus 1. Similarly, a plus b whole cube consists of a cube plus 3a square b plus 3ab square plus b cube, that means power plus 1. It has 4 terms. Similarly, the power plus 1 number of terms will be there in the expansion. That is a common understanding, and everybody can understand that. So to generalize this, this is given as a general term for whatever the term you want to find it out. And for the purpose of simplification further, what we do, we make a is equal to 1. If you make a is equal to 1, what happens? It is 1 plus x whole power n is nothing but sigma NCR into this becomes 1 power n minus r becomes 1 only, and it is x power r, and r runs from 0 to n. So understand that, put a is equal to 1, it will be simplified in this way, and the expansion will also be very comfortable for you. Like if you put r is equal to 0 here, nc 0 plus x power 0, nc1 x power 1, nc2 x square, plus so on and like this. So the bigger form will be simplified to this form by taking a is equal to 1 for our comfort. So if you replace x with minus x, what happens? Alternatively, you'll be getting plus minus, and by adding them, you'll get one expansion. By subtracting them, you'll get another expansion, and from this one you can further in the problems we will discuss some more concepts of the number of rational terms, number of irrational terms. If the base consists of irrational terms, and similarly the greatest term, numerically greatest term, and all this we will discuss further. Okay, so for the moment now, what I'd like to tell you, because this binomial theorem can of course be extended to trinomial and multinomial. Trinomial, multinomial means bi means 2 only, and if you go for tri means you will have 3 terms, and if it is multinomial you will have n number of terms. So like that, it can be extended with simple modification. What is that simple modification? Here, this is sigma, it is n factorial upon r factorial into n minus r factorial into a power n minus r into x power r. What we do, we write it as r runs from 0 to n. Then what we do here, we take n minus r is equal to some s. Let n minus r is equal to s, and thereby what happens? It is sigma n factorial upon r factorial into s factorial into a power s into x power r, and you can understand the sum of these, always see this, n minus r plus r is nothing but n, it is equal to power. It is equal to power always. So here also s plus r must always be equal to n. So now this can be generalized to any number of terms in the base. If you understand that, that will give you more comfort in solving the problems when 3 terms are given, 4 terms are given. here you are given 2 terms only, and if it is given 3 terms, then you can apply this one. So how it can be extended to more number? I will take the case of trinomial. Trinomial means 3 terms. 3 terms means I will make it in this way for your better understanding. x1 plus x2 plus x3 whole power n. Sigma will be of course the same. N factorial will of course be same, and I'll make the denominator like this: r factorial, s factorial, and t factorial, let me say. And you can understand that whatever the factorials are there, they are the powers of the terms in the base. Here also x1 power r, x2 power s, and x3 power t. Understand this please carefully. Such that the sum of the powers r plus s plus t must always be equal to n. This is called trinomial. Because you are all aware of binomial. From binomial, I have just created a formula for trinomial theorem also. It is nothing but the powers will come as the factorials in the denominator, and of course the power itself is in the numerator as factorial, and sigma notation, and sum of all these powers must always be equal to n. This is called trinomial theorem. So whenever the situation occurs, whenever such a problem occurs, you can make use of this. Of course, without using this also, you can solve using this binomial theorem, but it goes lengthy for you because you have to apply binomial twice in that case. If it is the case, you can get it directly. Okay, now let us go through first through some basic problems first, and later on we'll come to these beginning problems. Let us go to the second slide. Yes, let us see this one. The term independent of x in the expansion of 1 plus x. Term independent of x we need. Term independent of x in 1 plus x plus 2x cube into 3x square by 2 minus 1 upon 3x whole power 9. What is needed here? If you expand this, you must see this problem in this way. If you expand this, you will be getting 9 plus 1, 10 terms in the expansion. You will get 10 terms in the expansion, and all these 10 terms will be multiplied with 1, x, and 2x cube. And in all these terms now, what is our interest? We need such a term which is independent of x. Understand that. Independent of x means power of x must be 0. Power of x must be 0. Okay. So your thinking must be like this. This is to become independent of x. This is to become independent of x. It is a constant. It must multiply such a term in this one whose power must be 0, or it is nothing but x power 0, nothing but 1. So it must multiply with a constant term in this one. Then only that remains as independent of x. And if you come to this one, and it must multiply with x power minus 1. Understand that clearly. X power minus 1 plus 1, that becomes x power 0 is 1. And if you come to this one, x cube, and to make it x power 0, we need such a term in this expansion which is x power minus 3. So x power minus 3 into x cube, that becomes x power 0, which is 1. Here also 1, here also 1. That means there x will not be present. So in this expansion now, I need these three terms. That must be your understanding. Whatever the term you need, but take the help of general term, always general term. So let me write the general term for this one, 9CR. You all know that from your 10th class itself, you have this general term formula. It is NCR into 3x square by 2 whole power 9 minus r into minus 1 upon 3x whole power r. So this is nothing but, now what I do, I'll collect only the power of x. Power of x is here 18 minus 2r. And here in the denominator x power r, it is brought to the numerator. It is 18 minus 2r minus r. 18 minus 2r minus r. It is the power of x. Some constant is there, of course. We will see that later. Do you understand what I am doing here? This is the power of x in this case. That means, what is its coefficient then? 9CR will always be there. 9CR will always be there. And 3 by 2 whole power 9 minus r minus 1 by 3 whole power r. What did I write here? 3 by 2 whole power 9 minus r minus 1 by 3 whole power r. That's all I have written. But I want to see this term in three different cases. What are they? This must be equal to 0 in one case, and this must be equal to minus 1 in one case. This must be equal to minus 3 in one case. That means it may become 0 or it may not. We don't know. We have to equate and we have to check it out, because when 9CR is there, it is like NCR. R should always be an integer. Positive integer. R should always be a positive integer. That means it should be a natural number starting from 1. So when R becomes a positive integer, then only that is a valid value. Otherwise, you do not exist such a value. So here 18 minus 3R is equal to what? First case 0. Second case minus 1. Third case minus 3. Let me check it out now. This is 3r is equal to 18 by 3 is 6, or if you write minus 1, 3r is 19. Not possible. Do you understand why it is not possible? It is 3r is equal to 19. R is equal to 19 by 3, which is a fraction, but r will never be a fraction. That is why the term x power minus 1 will not exist in this expansion. That must be your understanding. The term x power minus 1 will not exist in this expansion. That must be your understanding. Let us see this one now, minus 3. If you write minus 3 here, 3r is equal to 21, r is equal to 7. This term exists and this term exists. Understand that. So there are two terms in the expansion. From that one now you have to write the term independent of x. So this is what the procedure to find out the term independent of x. If it is individually given without this factor here, without this coefficient here, if it is individually given, this is what the procedure to find out the term independent of x if it is equated to 0. If it is equated to 0, what happens? R is equal to 6. So if you put R is equal to 6 here, you can check it out. R is equal to 6 here. 2 into 6, 12. 12 minus 6. Minus 12 minus 6, 18. 18 minus 18, 0. That's what we did here. So x power 0. So whatever the term remains, it will be constant always, which is term independent of x if it is individually taken. But it is not individually taken, but it is multiplied with this one. So what are the values of r we have got here? Remember, r is equal to 6 and r is equal to 7. Now let us see this now. Let us see this. Therefore, term independent of x is equal to, this is 1, should be multiplied with x power 0, x power 0. So if x power 0 is there, then r should be 6. Then what should it be? Put r is equal to 6 here. 9c6. And it is 3 by 2 whole power 9 minus 6. And it is minus 1 by 3 whole power 6. Do you understand what I am doing now? I am collecting the constant term or term independent of x through the multiplication with 1. So first term done. What about the second term? No need of taking second term because here it is not equal to minus 1. So x power minus 1 term will not be there in this expansion. Take it as granted. But x power minus 3 term is there or not? It is there. That is why you have got the value as a positive integer. R is equal to 7. Now substitute r is equal to 7 in this one. So for that purpose, what you have to do here, you have multiplied this particular term with 2x cube plus twice of. Put r is equal to 7 there. What should it be? 9c7 into, you need not have to take this, 3 by 2 whole power 9 minus 7, 2, and here it is minus 1 by 3. R is 7 here. R is 7 here. R is 7 here. R is 7. 9 minus 7, 2. And 9c7, R is 7 here. This is already equated to be minus 3. You need not have to write x here. So if you simplify this, you must get the term independent of x in this expansion. That's what the procedure is. So because you are all aware of finding the independent term without this multiplication, without this factor, you all know how to do that by simply equating to 0. You can do that. That means you will have only this one as term independent of x in this expansion. But when it is multiplied with this one, there is an extra term added here. Okay? So now you have to simplify this to get the final result. It is 9c3 is 9c6 is same as 9c3. So 9 into 8 into 7 upon 3 into 2 into 3 cube by 3, 3 square by 2, and you will have minus there. This is minus. Of course, this is 3 power 6. Okay, that becomes plus only. This is 3 power 6. This is 3 cube. So 3 cube by 3 power 6. Let me write this 1 by 8, 3 cube by 3 power 6, 1 by 3 cube remains, 3 cube means 20, 9, 3 is 9, 3 is 27, plus 2 into, it is 9c2, 9 into 8 upon 2, 9 4 is 36, into 9, this is 3 power 7. This is minus only. So minus 1 upon 3 power 5 remains. So 1 upon 4 is this one into 1 upon 3 power 5 is 9 into 9, 81 into 3. 81 into 3 is 243. This is to be simplified to get the term independent of x. If you simplify this, you will get the options. Okay, the simplification all you can do that. That is why I am leaving it to you. You can do that. If you know the procedure, then all this can be done easily. Okay, and you cannot write any direct steps for this one. Like you have some formula to find out the term independent of x to write the value of r directly, but you don't need to take that. If you work out this at pace, that means if you practice it, you can write the direct steps and you can simplify this in this way. Okay, this is one of the important models in the binomial theorem. Okay, next one, the term independent of x in 1 plus x plus 2x square into 3x square by 2 minus 1 upon 3x whole power 9. Same model, except that 1 plus x plus 2x square is there. 2x square is there. That's only the difference. The same procedure you can follow. You can get the answer easily. Okay. So note down the problem and practice in the similar way. Okay, let's go through the next slide. The coefficient of the term independent of y in the expansion of the coefficient of term. These are all, many of them are previous questions, of course, maybe of the same model you can expect in the previous questions, like the models are taken from the previous questions only. So if you thoroughly do this, and you will build up the confidence levels first, so that you can solve the similar models with ease. Okay, the coefficient of the term independent of y in the expansion of y plus 1 upon y power 2 by 3 minus y power 1 by 3 plus 1 plus minus of y minus 1 upon y minus y power 1 by 2. Whole power what? Whole power 10 is given. Whole power 10 is given. So from this one you have to find the term independent of x. When you see this term, you must remember a cube plus b cube formula, because a cube plus b cube formula is a plus b into a square minus ab plus b square. This is what the formula. To simplify this, when a plus b is given, this becomes a rationalizing factor. When this is given, this becomes a rationalizing factor. That's what your understanding must be. So what should be a square here? Y power 1 by 3 whole square minus y power 1 by 3 into 1. So what I do now, I'll first simplify this by simply multiplying and dividing with a plus b. What is a in this case? Y power 1 by 3. So y power 1 by 3 plus 1 divided by what I'm doing now, I'm multiplying this factor with y power 1 by 3 plus 1. That means when I multiply this denominator with this one, it will be in the form of a plus b into a square minus ab plus b square, which is nothing but this form. In this form, what happens? It takes the form of a cube plus b cube, and thereby this power 3 will be getting cancelled. And here also this becomes 1 only. So what else remains? You can, by now you might have understood, y plus 1 remains in the denominator after rationalization. After rationalization, y plus 1 remains, and thereby these two will be getting cancelled. Minus of, and if you see the denominator carefully, and I'll take root y common, it is root y minus 1. What I'm doing now, I'm rationalizing the denominator, that is root y plus 1 multiplied and root y plus 1 divided. Whole power what? 10. So now whatever is remaining, we are going to write that y power 1 by 3 plus 1, and it is a plus b into a minus b, a square minus b square. That means y minus 1 remains, and this will be getting cancelled. These two, this will be getting cancelled. And what else is remaining is root y plus 1 upon root y. Root y plus 1 upon root y. Let me split it now. Root y upon root y, 1 plus 1 upon root y. Do you understand what I'm doing here? These two anyway will be getting cancelled with this one. Root y upon root y is 1 plus 1 upon root y. It is written. So 1 minus 1 getting cancelled. Whole power 10 now. So y power 1 by 3 minus y power minus 1 by 2 whole power 10. So far we have not applied binomial theorem, any concept of binomial theorem. Any concept of binomial theorem, simply we have simplified these asserts. We have applied the concept of rationalization. So this is a problem in binomial theorem which involves asserts also. surds also, surds plus binomial theorem. Okay, now you have got it to the standard form. In this one, you need the term independent of x. So for that purpose, let me write the general term. The general term is NCR into x power n minus r into y power r. That's what it is. This term here and this term totally here. This is the general term. But what we need here, that's our primary goal, is we want to have such a term where the power of y becomes 0. Power of y becomes 0. But we have taken a general term for this expansion. In this general term, what we do now, we just take the power of y and we equate it to 0. Why should it be done? Because we need the term independent of x. So, to have a term independent of x, let me write for your better understanding. It is 10 minus r upon 3. 10 minus r upon 3. It is in the numerator. Of course, it is also in the numerator. And what is it? If you multiply this, a power m whole power n. A power m whole power n is nothing but a power m into n, the formula, indices. So what is it? Minus r by 2. That will be added to this. What is that? It's power of y taken together. Power of y taken together, and hence it becomes 0. It becomes 0. If you take LCM and if you simplify this, it is 20 minus 2r minus 3r is equal to 0, and r is nothing but 4. So whenever you take a particular expansion, this expansion may have or may not have the term independent of x. That should be your understanding first. This expansion may have or may not have the term independent of x. If you get a numerical value, positive integral value, positive integer for r, then you can say that definitely there will be independent of. If you get any fraction or negative value, you have to take it as granted that in this expansion you will not find any term independent of x. Of course, here independent of y, whatever it is, independent of y, because the terms are in y. So r is equal to 4. Therefore, required term, what is to be written here? Write r is equal to 4 here. It is 10c4. 10c4 into, you have minus 1 whole power 4. This one. Need not be written because that becomes plus 1 there, plus 1 there. Now what is 10c4 here? 10c4, simplify this to get its value. It is nothing but 10 into 9 into 8 into 7 upon 4 into 3 into 2. These two getting cancelled, and it is 3, and 210 is the required answer for this one. You can check the options there. It is 210. The similar model, the next one, the absolute term independent of x in the expansion of root x minus k by x square whole power 10 is 405, then k is equal to, it is, problem is twisted a little. So far what we did is, we have find out the term independent of x, but there he has already given it in the problem. In the problem it is already given, and some unknown quantity is given to be k there in the question. Unknown quantity k is given, whose value is to be find out. It is very simple, the same procedure you follow, and finally this value is given, then equate that to, write the term and equate that to 210, then you will get the value of k. So let us at pace, let us work out that. You will understand in a better way. what is a root x minus k by x square whole power 10. Its a term independent of x is given to be 405. So let me write the general term 10 CR into root x whole power 10 minus r. So 10 minus r upon 2. What is this upon 2? Root x is written like that. Into minus k whole power r will be there. Into by x square is there. Comes to the numerator. X power minus 2 whole power r. That becomes minus 2r. This is the general term, please. R plus 1th term. To have an independent term, what should it be? The power of x must be 0. What is it? 10 minus r upon 2 minus 2r is equal to 0, which is nothing but 10 minus 5r is equal to 0. R is equal to what? 2 here. R is equal to 2. So substitute that in this one now. 10z2 into, you need not have to touch x here because we have fixed its power as 0. Even if you substitute r here, you will be getting x power 0 only. You will be getting x power 0 only. So minus k whole power 2 is equal to, that's all. This is a term independent of x. What is given there? Please go to the question. It is given to be what? 405. Given to be 405. Now what is 10c2? 10 into 9 upon 2 into k square is equal to 405. It is 45. K square is equal to 405 upon 45 is nothing but k is equal to k square is equal to 9. K is equal to plus or minus 3. The same problem twisted like this. Same problem in this one. Some unknown quantity k is given and the term independent of x is already given. So from that one we have got the value of k. Similar is the similar model but little twist like that. Okay, so plus or minus 3 is the third option, is the correct one. Okay, let's go through the next one. It is also similar. You can see that the greatest value of the term independent of x as x varies over r in the expansion of x cos alpha plus sin alpha divided by x whole power 20 is. You can do that in the similar way, and you know the range of sin alpha and cos alpha. Range of sin alpha cos alpha is closed minus 1 comma 1 closed. Based on that, you can solve the problem. Okay, now let's go to the next one. The sum of the rational terms in the expansion of. This is an important model and which involves your attention in solving this type of problems. Let us go to the problem again. The sum of the rational terms in the expansion of root 2 plus 3 power 1 by 5 root 2 plus 3 power 1 by 5 whole power what? 10 is given. You need the sum of the rational terms. First of all, you understand what is this rational term? What is that irrational term here? You think in this way. When you expand this using binomial theorem, how many terms will you be getting here? You will be getting 11 terms. Don't forget that. You will be getting 11 terms. Among these 11 terms, some terms consist of square roots and fifth roots or whatever the roots are there. I repeat, when you expand this, in this expansion, you will get 11 terms. In these 11 terms, some terms will be consisting of roots and some terms do not. Some terms will be consisting of roots, square roots or cube roots or fourth roots or fifth roots, but some terms do not have any roots. The terms which do not have any roots, then they are said to be rational terms. Simple. They are said to be rational terms. So such terms are to be found out in this case now, and such rational terms, how many will be there in these terms? We don't know, and which is to be found out. And if such terms exist, we have to find the sum of all such rational terms. whatever the situation it is, you always go through the general term. What is the general term for this one? TR plus 1 is nothing but 10CR into, I will write direct step here, 2 power root 2 whole power 10 minus R, which is nothing but 2 power 10 minus R upon 2, because root 2 power 1 by 2. No confusion. Into 3 power R by 5. This is what you have got here now. But by 2, by 5 are there, then it becomes square root 2. This becomes fifth root 3, like that, which are not needed for us. We should not have such terms because we need only rational terms. For that purpose, you always think in this way. You must have such a common factor in this numerator and in this numerator. I repeat, you must have such a common factor in this numerator and as well in this numerator, which should be a factor for 2 and 5. Which should be a factor for 2 and 5. Simple understanding. Take LCM of 2 and 5. That's all. Take LCM of 2 and 5. What is LCM of 2 and 5 in this case? It's nothing but 10. Okay. Now let us try by taking R is equal to 10. If you substitute R is equal to 10, 10 minus 10, 0 by 2, 0. 2 power 0, no root. If I write 10 here, 10 by 5, 2, 3 square, 9, no root here. If I write 0 here, then 10 minus 0 by 2, 10 by 2, 5. And if I write 0 here, it is 0 by 5, 3 power 0, 1, like that. So when LCM of 2 and 5 is 10, understand if you have more and more terms, because you have only power 10 here, you will be getting only 11 terms in the expansion, but it may be given power 100 also. Power 100 also. In such a case, what happens? You have to take 10, you have to take 20, you have to take 30, 40, 50, 60, 70, 80, 90, up to 100 you have to take. Then thereby you will be counting all the existing rational terms. But here in this case, it's a simple problem because the power is 10. You'll have only 11 terms in the expansion. So for your better understanding, what I'm doing now put R is equal to 0, 10. By now you might have understood why we are putting 10 here, because 2 and 5 LCM is 10. If you put 10 here in this one, that will become a common factor for both of this, and thereby the square roots or fifth roots will be getting cancelled. So put R is equal to 10, what will it be? R is equal to 0, what will it be? It is T1. Are you with me? R is equal to 0, T1. It is 10C0 into 2 power 5 into 3 power 0. Put R is equal to 10. 10 plus 1, 11. Then 10C10 into 2 power 10 minus 10, 3 power 2. That means you understand the first term is rational, and again the last term is rational. First term is rational, again the last term is rational. In between, all the terms are irrational only. That means how many rational are there, how many irrational are there? Only 2 rationals are there, and remaining all will be irrational only. That is, if you have 2 rational terms, there will be 9 irrational terms, because in the total number of terms in the expansion will be 11. Among them 2 are rational, remaining will be irrational only. Now it is 2 power 5, it is 32, and it is 3 square 9, it is 32, and the sum of this is equal to 41 should be the option there. So if you go through that option, it is 41. It is 41. So we must think in a broad way to understand this problem with regards to rational terms and irrational terms. We can take a general formula for this one as as if you remember, I explained you the procedure not to miss the concepts. You need the conceptual strength. So you can apply a formula also for this one. I'll give you a formula for this. Number of rational terms is equal to number of rational terms is equal to step of, that is greatest integer function, step of n upon LCM of P comma Q. What is this P comma Q? I'll explain you. Step of n upon LCM of P comma Q in the expansion of P root x plus Q root y whole power n. Do you understand what I am doing here? P root x plus Q root y whole power n. N is taken, LCM of P and Q are taken. That's what we did here. LCM of 2 and 5 are taken. LCM of 2 and 5 are taken. Now, what is n here? 10. What is LCM of 2, 5 here? 10. So 10 by 10, it is 1. And you must have plus 1 for this. So the number of rational terms formula is this. Step of n upon LCM of P comma Q plus 1 in P root x plus Q root y whole power n. If you need irrational terms, then whole power n is there. The number of terms will be n plus 1 and subtract the number of rational terms from the total number of terms. That's all. It is n plus 1 minus number of rational terms will give you number of irrational terms. Understand that, please. Okay. So this is an important model, and of course I think it is also a previous question. So in this one, what you have to find out? You have to find out the number of rational terms. If you want to take a formula, the general expansion for binomial theorem, let us take the binomial expansion as P root x plus Q root y whole power, and in this one, if we need number of rational terms, it is step of n upon LCM of P comma Q plus 1 is the formula. You can note down that formula and you can apply anywhere you like. This step stands for the greatest integer function. You all know about that. Okay. Next. The number of real negative terms in 1 plus ix whole power 4n minus 2. Number of real negative terms in 1 plus ix whole power 4n minus 2. What are the conditions given there? N belongs to capital N and x is greater than 0. We need number of real negative terms. In this expansion. Okay. Let us see here. I is there, stands for imaginary number. I square becomes minus 1. I cube becomes minus I power 4 becomes 1. So let us write few terms in this one. 4n minus 2 C0 into 1, I am not writing that, plus 4n minus 2 C1 into 1, not needed to write, plus 4n minus 2 C2 into Ix whole square, plus 4n minus 2 C3 into Ix whole cube, plus 4n minus 2 C4 into Ix whole power 4. We need real negative terms. The term must be real and it must also be negative. Negative means here it is possible. I square is there. I square becomes minus 1 and hence you will get minus here. I am removing it now. This is minus 1. Which term it is? First, second, third. So, third term. Next you imagine I power 4 becomes 1 only, but it is not negative. It is not negative. Next I power 5 becomes I. Next I power 6 becomes I power 4 into I square, which is nothing but minus 1. So, which should be next negative term? Understand 4n minus 2 C5 will not be the negative term. 4n minus 2 C6 and so on. Whatever is required, I am writing that. C6, C5, next is C6 into Ix whole power 6. What is it? I power 6. What is I power 6? I power 4, 1. I square minus 1. So, I am putting minus before this. I am removing I here. What is the number of this term? Number of this term is 7. So, third term, seventh term, and next will be third term, seventh term. Difference is 4. Next one will be 11th term, and so on, and so on. You need how many such negative real terms will be there in this expansion? Okay. So, we have got it to be a series in the form of a series 3, 7, 11 like that, and the number of such terms are needed for us. And in this expansion, what should be the last term? 4n minus 2 plus 1 is the last term. 4n minus 2 plus 1 is the last term. So, in this series, what I am doing now, I am just finding the nth term in this expansion. Now, if you find out the nth term in this expansion, a plus n dash minus 1, because n is already used here, into d must be equal to, let us equate to this one. Check it out. Let us check it out whether it forms a relation or not. Then n dash 4n dash minus 1 is equal to 4n minus 1. Now, your n dash becomes now n. Your n dash becomes now n. What does it mean? The number of terms in this expansion are 4n minus 2 plus 1. Among this, I need those terms which are real negative terms. They must be real and as well the negative terms. That's what I have formed a series, and I have got the nth term and equated, and I have got it to be n dash is equal to n. So, how many such terms will be there? N such terms will be there. And if you go to the next problem, it is similar to the previous problem. The number of rational terms in 1 plus root 3 plus cube root 3 whole power 6. You try in the same manner what I gave you previously, but it consists of 3 terms. You try it on your own and try to solve this.